Welcome for today's lesson. In our previous lesson, we discussed on how we can be able to draw a graph using two given points. So in today's lesson, we want to learn how we can be able to draw a graph and at the same time determine the gradient and the y-intercept of that particular equation without necessarily drawing the graph. So to begin with, we shall consider an equation of the form y is equal to 2x plus 1. So we want to understand the meaning of 2 and the significance of the constant 1. So to understand the significance of 2 as far as the linear relation is concerned and the significance of 1, we can be able to plot a table for this particular relation and see what is the significance of 1 and what is the significance of 2 from that particular relation. So when the value of x is 1, we substitute in our relation and we find that when x is 0, the y value will be 0 plus 1, which gives us 1. We substitute the value of x as 1 and obtain the corresponding y value. So in this case, the y value will be the y value will be 2 times 1 plus 1, which gives us 3. Those 2 points are enough to draw the straight line. So we can be able to represent the coordinates as 0, 1 and 1, 3. If we join the 2 points, that is 0, 1 and 1, 3, we shall be able to obtain a straight line graph. So in that particular straight line graph, we can be able to find the gradient of that graph by introducing a right-angled triangle between the 2 points, that is 0, 1 and 1, 3. So having introduced the right-angled triangle, we can be able to read off the run as 1 unit, that is from 0 to 1. The x-coordinate starts from 0 and ends at 1, so the run is 1. 1 minus 0 is 1. then the rise in this case will be 3 minus 1, which gives us a positive 2. So the rise is positive 2 and the run is positive 1. So what will be the gradient of that particular line? From our initial formula of calculating gradient, we did mention that gradient is obtained by taking the rise divided by the run. In our case, the rise is positive 2 and the run is positive 1. That gives us a gradient of positive 2. We also need to calculate or to read off the y-intercept. In our previous lesson, we did mention that y-intercept is a point where the graph cuts the y-axis. So in our case, our graph y is equal to x plus 1 is cutting the y-axis at 1. And therefore, the y-intercept is 1. Now, from our relation that we have been given, that is the equation, we can be able to compare what 2, where there is 2 in our relation, and where there is 1 in our relation. So in this case, we discover that the 2, which is representing gradient, is the coefficient of x. And therefore, we can conclusively say that the gradient is the coefficient of x. Then we can also conclusively compare what the constant 1 represents. And in our case, the constant 1 represents the y-intercept. Now, from these two quantities, we can now be able to write a general gradient intercept form of an equation, which is normally written as follows. So the general equation of gradient intercept form is normally in the form y is equal to mx plus b, where b represents the gradient, where m represents the gradient, while b represents the y-intercept. So when we express all our equations, linear equations in the form y is equal to mx plus b, we can be able to read the gradient of that line by just reading off the coefficient of x. We can also be able to identify the y-intercept by reading off the value of the constant b. So let us look at an illustration which can be able to assist us read off the gradient and the y-intercept without necessarily drawing the straight line graph. So in our example 1, we shall consider the following three equations. State the gradient and the y-intercept for the graphs of the following relations. Now, without drawing, we can be able to state the gradient and the y-intercept of the graphs for the following relations by, first of all, writing down the gradient-intercept form of the equation. Y is equal to mx plus b, where m represents the gradient and b represents the y-intercept. So when you look at our first case A, y is equal to 2x plus 1, it's already in the form y is equal to mx plus b. So in this case, you don't need to rearrange the relation. We just compare the corresponding values. So in this case, m is 2, which is the gradient, while y-intercept, b is positive 1, which represents the y-intercept. That means if we draw this graph or we sketch, the graph will pass through y is equal to 1, and the gradient of that graph will be 2. Now, let us look at the next equation. What is the gradient and what is the y-intercept for part B when the equation is y is equal to negative 3x? Now, the first step is to write down the general gradient-intercept form of the equation of a straight line, which is written as y is equal to mx plus b. So when you look at our relation which you have been given, the constant term is missing, and therefore we can say is plus a 0. Is equivalent to plus a 0. In this case, the gradient is m, the gradient m, the gradient m will be negative 3, while the y-intercept b is 0. That means this particular line is passing through the origin, and the gradient of that line is negative 3. So it's very important to know that note that when the coefficient of x is a negative value, you identify the gradient by picking the value including the negative sign. In this case, we picked negative 3 as the gradient because the negative sign is inclusive. Let us look at the part C of our question or our example. In part C, the equation is 2x plus 3y is equal to positive 6. You will notice that in this particular equation, it has not been arranged. So there is need for us to rearrange the equation in the form y is equal to mx plus b. To rearrange, we need to, first of all, subtract 2x from both sides. Once we subtract 2x from both sides, the x will be eliminated on the left-hand side. Then, divide both sides by the coefficient of y to make y the subject. Three and 3 cancels. We are left with y. On the right-hand side, negative 2 over 3x plus 6 divided by 3 is 2. And therefore, the equation is in the form y is equal to mx plus b. Having expressed the equation in the form y is equal to mx plus b, we now compare the general gradient intercept form, which I'm calling equation 1, and what we have expressed. So in this case, m corresponds to negative 2 over 3. M, which is the gradient, is equal to negative 2 over 3. Then b is equivalent to 2. Therefore, we can read off the values of gradient as negative 2 over 3 and the y-intercept as positive 2. So that is how we can state the gradient and y-intercept using gradient intercept form of the equation of a straight line. Now, in our second case, we shall be sketching linear graphs using the gradient and y-intercept. So that will be our example 2. How do we sketch linear graphs using gradient and y-intercept? We can be able to illustrate this using an example as follows. Find the value of the gradient and y-intercept for these relations and sketch the graphs. Now, the illustration reads as follows. Find the value of the gradient and the y-intercept for these relations and sketch their graphs. So in part A, the relation is y is equal to 2x minus 1. And in part B, x plus 2y is equivalent to 6. Let us start by discussing part A. Y is equal to 2x minus 1. We first of all identify the gradient of that particular relation, get the y-intercept, then having the two, we can be able to use them to sketch the graph. So the first step we do is that we write down the gradient-intercept form of the equation of a straight line as y is equal to mx plus b, where m will be the gradient and b the y-intercept. So from our relation in part A, y is equal to 2x minus 1, it means that the gradient m is 2 and the y-intercept is negative 1. So having identified the y-intercept and the gradient, we can be able to go ahead and sketch that particular graph. So the first thing we do is to locate the y-intercept. We locate the y-intercept as a point. So because we understand that y-intercept is a point where the graph carries the y-axis, it means the x value is 0. So the point is located at 0, -1. We go and plot that on the Cartesian plane where there is 0, -1. So the 0, -1 point is indicated. Having located that point, we now need to write down the relation for finding gradient. We know that gradient is given by a rise divided by the run. The run is always positive, and in this case, our gradient is 2. 2 can be expressed as 2/1. That means we shall run across 1 unit. Then upwards 2 units. Because the rise is 2 units, it means we are moving upwards. It's positive. If the rise is negative, then it means we are moving downwards. But in our case, the rise is positive. So it means we are moving upwards 2 units. The run is 1 unit. It means we are moving to the right 1 unit. Or in other words, we can say we are moving across 1 unit from our y-intercept point. So you start at 0, -1, then you move across 1 unit. That means we end at 1, -1. Then you move upwards 2 units. So we have moved 1 unit from our y-intercept across, then upwards 1 unit for the rise, upwards 2 units to represent the rise. So where we end is our next second point of plot. So that means our second point, I'll call it P2, will be represented by 1, 1. Then having the 2 points, we can be able to join to obtain the straight line graph. So that line we have obtained is now the line y is equal to 2x minus 1. And that is how we use gradient y-intercept to sketch the graphs. Try part B of the question, which reads x plus 2y is equal to 6. Okay, now in the second part B, we want to express the equation x plus 2y is equal to 6 in the form y is equal to mx plus b. So what we do, we subtract x from both sides. In this case, if we subtract x on the left-hand side, it cancels out. We remain with the 2y is equal to 6 minus x. At this point, we divide both sides by 2 to make y the subject. So if we divide the left-hand side by 2, we remain with the y. Six divided by 2 is equivalent to 3. So we can be able to rearrange this equation so that it is in the form y is equal to mx plus b. So the equation has been written as y is equal to negative a half x plus 3. So it's now in the form y is equal to mx plus b. So at that point, we compare y is equal to mx plus b with our relation that we have obtained, y is equal to negative a half x plus 3. So if we compare correctly, it implies that m, which represents gradient, is equal to negative a half. That is the gradient. Then the y-intercept which is b, is positive 3. At this point, we can be able to locate the y-intercept. Because the y-intercept is a point where the graph cuts the y-axis, its x-coordinate is 0, and the y-coordinate will be 3. So from our graph, we can be able to locate that point 0, 3. Then, we now look at the gradient part. We said the gradient is rise over run, which is equivalent to -1/2 in our case for this particular relation. So we assign, or we link, the negative sign with the rise. But the run is always positive, as we had noted earlier. So at that point, it means we shall move to the right 2 units from our point. From the point P1, our y-intercept point P1, we shall move 2 units across, or we can say we can move 2 units to the right. When we move 2 units to the right from our y-intercept, you notice that we are now at point 2, 3. So at that point, you now move 1 unit downwards because the rise is -1. It means we shall move 1 unit downwards. Negative sign means downwards. So if we move 1 unit downwards, we notice that we are at point 2, 2. That is our second point. We shall call that point P2. Once you have the 2 points, P1 and P2, you now take a ruler and join the 2 points to obtain the straight line for that particular linear relation. We go ahead and define our graph as y is equal to -1/2x plus 3. So you'll notice that our graph is cutting the x-axis at 6. That means the x-intercept is 6 after extrapolation. And our graph cuts the y-axis at 3. That means the y-intercept is 3. And the gradient of our graph is -1/2. Let us now look at another case 3 on how you can decide if a point is lying on a given line. We shall call that example 3. So in that particular example, decide if the point -2, 4 is on the line with the given rules. Part A, the relation is y is equal to 2x plus 10, and in part B, y is equal to -x plus 2. So how do you handle part A? To decide if this point -2, 4 lies on this particular line, y is equal to 2x plus 10, we can be able to do that by substituting the value of x is equal to -2 into this relation and find out if we shall be able to get the y value as 4, then we shall be able to conclude that it's lying on a straight on that particular line. But if you substitute x is equal to -2 in this particular relation, and the result we obtain for the y value is any other number other than 4, then we say the point -2, 4 is not lying on the straight on that particular line. So for the point -2, 4, it means the x value is -2, while the y value is +4. So substitute x is equal to -2 into equation. Into equation y is equal to 2x plus 10. This will give us y is equal to 2 into -2 plus 10, which simplifies to y is equal to -4 plus 10, which gives us 6. So we are getting the y value as 6 when we substitute x value as -2. So you'll notice that 6 is not the same as 4. So the moment the value of y is not the same as the value of y given in the point, on that particular point, then it therefore implies that the point is not lying on that particular line. So we can be able to conclude that therefore point -2, 4 is not on the line. So point -2, 4 is not on the line because we are getting the y value as 6 instead of getting the y value as 4. Try part B. Again, we substitute the value of x is equal to -2 into the relation y is equal to -x plus 2. So this implies that y is equal to negative into negative 2 plus 2. A negative times a negative, the result is positive. So we are having 2 plus 2, which is equal to 4. So in this second example, the value of y is 4, which is coinciding with the value of the point. Because the point, where the values of the point when substituted in the equation must satisfy the equation. So in this case, the value of y is satisfying our equation. And therefore we can say, in conclusion, that the point negative 2, 4 is on the line. The point negative 2, 4 is on the line y is equal to negative x plus 2. That's basically how we can be able to decide if our point is on the line or not on the line, by simply substituting the coordinate for x and identify the coordinate of y. Once you have obtained your coordinate of y, compare with the coordinate of y for the point which was given. If the coordinates of y coincide or they are the same, then we say the point is lying on the line. But on the other hand, if the y coordinate obtained is not the same as the y coordinate for the point given, then we conclude that the point is not lying on that particular line. So we wish now to extend the knowledge of gradient and y-intercept to this concept of finding the equation of a line using y is equal to mx plus b. How do we find the equation of a line using y is equal to mx plus b? So in our first illustration, we wish to find the equation of a line given the y-intercept and another point. For example, determine the equation of the straight line shown. Now, when we study this particular line that is given, this is the line that we want to determine its equation. We need first of all to identify the y-intercept, because we want to find the equation of a line using y is equal to mx plus c. So that means y is equal to mx plus b. Sorry. That means we require the gradient, which is m, and we also require the constant b, which is the y-intercept. So in our first step here is to study the line and identify y-intercept. So in our case, we shall represent y-intercept by b. So b is equal to -4. That means already we have b. We now need to go further and find the gradient m. Gradient m is given by rise over run. So in this case, we look at this point. We choose any 2 points on that particular line. I've represented the 2 points with a dot. So in the first point is -2, 0, and in our next point is 0, -4. So if we consider the point -2, 0, then the run we shall move across. If we consider the right-angled triangle, we shall move across 2 units. Then we shall move downwards 4 units. So because we have moved downwards, we represent that by a negative. So we shall link the rise with a -4, and the run is always positive, which is 2. So we substitute in our equation of a gradient, which is equal to rise over run. In this case, rise is -4 over run is +2, which gives us -2. So that means the gradient of this line is -2. We now replace where there is m with the -2 and where there is b with the -4. So our final equation becomes y is equal to -2x minus 4. And that is the required equation. We say we have obtained the equation of a line using y is equal to mx plus b by just substituting the values of gradient, which is m, and substituting the value of the y-intercept, which is b. Then in our last example, we wish to find the equation of a line given the gradient and a point. That will be our example 2. So in that example 2, we are required to find the equation of the line that has a gradient of a third and passes through the point 9, 2. So we need to know that the general equation of any straight line is given in the form y is equal to mx plus b, where m represents the gradient and b represents the y-intercept. So in our case, the gradient is a third. M is a third, is already given, so we can say given. Then it passes through the point 92. The point is 92 means x is equal to 9 and the y coordinate is 2. Now what we do, we replace in our equation where there is y with the 2 and where there is x with the 9 to find the value of b. So in short, find b. To find b, substitute in this general equation. Suppose I call it Roman 1. Substitute m is a third, x is 9 and y is 2 in 1. In 1, where 1 means y is equal to mx plus b, which is the general equation of any straight line. If we do substitution, it will be y, which is 2, is equal to m, which is a third, x, which is 9, plus b, which is unknown. A third times 9 is 3, plus b. This implies that the value of b will be obtained by taking 2 minus 3, which is negative 1. So we have m is a third and b, which we have calculated as negative 1. Therefore, the equation of that line will be y is equal to, we now replace where there is m with a third, x, then where there is b with the negative 1. And that becomes our equation for that particular straight line. Now that marks the end of our lesson, and in brief, we have been looking at gradient and y-intercept form. We have made use of that knowledge to find the equation of a line in the form y is equal to mx plus c. So at that point, we stop there, and thank you.